You and I are together going to look at the MQTT traffic going on in our system when we subscribe and when we publish. We have the system here in two diagram versions. The diagram on the right-hand side is very detailed in terms of virtualization. We don't need all that, we only need the diagram over on the left-hand side, which is our conceptual understanding. So let us move and let us bring up Workstation to start capturing MQTT packets on our system. And here we are on PC1. On PC1, we will be running the publisher program. This is the program in its entirety. Over on PC2, we will have the broker running. Let us run the Mosquito subscriber utility on the broker so we can see what is being published. The question now is, where do we want to do our packet capturing? I suggest that we capture in two places, namely on the MQTT publisher and the MQTT broker interfaces. So let's set that up. As we are on the broker, we will start here. I'll open a new terminal. And here we have Wireshark. It's already pointing at our interface, Ethernet 0 interface. Double-click that, and we are capturing. One way to not pollute our captures with the smartphone and host computer communication would simply be to filter that communication out. Let us stop the capture here on PC2, also over on PC1. We can decide how much we actually want to capture, how much we want to put into our capture file. In order to put a cap on how much we're capturing, we can click the Capture Options button here. Down here in this field, we can enter a capture filter that will limit the amount of package that we are actually capturing. We know that all our traffic is going to our TCP port 1883, which is the default MQTT port on our broker that we are using. Put in this capture filter here, but remember that you have it there, because if you want to see all package, you will have to take that filter away. Start capturing. We will do the same over on PC1 for our interface. We are capturing. Here on PC1, we will do a publication to the broker. 9 was published. And we can see that we have a capture over on Wireshark. If we go to PC2, we can see that we have the same capture. It should be the same as we are actually Wiresharking on the same connection between the two devices. From here to here. A difference between the two captures would have indicated that something was wrong in the communication. It's practical to have a good time reference in our captures in order for efficient and searching for possible errors. So let us tweak the time settings here. Go to the View menu, Time Display Format, and we want the time to be in seconds. Go to the Time Display Format again, and you have to choose here what is practical for you, what you're going to use your capture for. I would like here to simply see the second since beginning of capture. That will do for us, and it is the default setting. The first capture we made here of these 4 packages were actually within 1 second. Let us move over to PC1 and do the same there. It might seem unimportant, but to have efficient documentation of what we're doing, we would like to change the font here to a bigger size. (16). And also set the time reference here to seconds. What we are seeing here is the application layer communication between broker and publisher on address 61 and 64 respectively. Let us look at our network diagram from another perspective. So what we have here is the internet there. This is router 1. And this over here on the right-hand side is also router 1. We have our network 192.168.10/24. And here we have our broker. The broker on the left-hand side here is drawn with all the TCP/IP stack layers from physical, data link, network. And this layer here is the transport layer. This is where we have our port numbers. And at the top here, this is where we have our application. And the broker is sitting right over here. On PC2, there's also an HTTP Python server running and an Nginx server running. We can see that those two devices are on port 8000 and port 80 respectively. We know that our broker port is 1883, so let us put that in there. We also have our publisher over here on the left-hand side diagram. This is the TCP/IP stack for the publisher. All the TCP/IP layers are shown, and we have the transport layer here with the port numbers, and at the top we have the applications. Here, this is my publisher Python program running in that place. We see that the two Firefox programs are on different ports. So now the question is, what port is my publisher Python MQTT program sending from and receiving on? We know that the broker is sending from and receiving on port 1883. The answer will be given to us from Wireshark. Let us bring up Workstation again. We were running our Python publisher program on our publisher machine on .61, and that connected over to the broker on .64. Those were the IP addresses. If we click the number 4 capture here, we will here in the center pane see that for this particular frame, the destination port was 1883 as expected. And here we have it. The source port over from the publisher is 59531. We can type that in over in our diagram, 59531. That is where our Python publisher program is sending from and receiving on, i.e. this is the connection at the transport layer between our two devices, the broker and the publisher, on these two ports. So in Wireshark, the application layer, which is at the top when we draw graphically our TCP/IP stack, is here at the bottom in Wireshark. The transport layer is next. Then comes the network layer with the IP addresses, then the data link layer with the MAC addresses, and finally the physical layer with all the bits and bytes very close to the electrical signals. At the application layer, we have captured the MQTT communication between devices. The ports at the data link layer, the IP addresses at the networking layer, the MAC addresses at the data link layer. It is very rarely that you'll have to look at the physical layer, what is going on there. This is Wireshark terminology, so let's get back to looking at our MQTT packages. The most interesting to look at here is the message that was sent. We can see here at the application layer that we have message queue telemetry transport, and lo and behold, what do we have here? We see that we can plain text see the topic, plant 1 temperature, and the message that was sent was the 9. Further on at the application layer, this is where we will be working, we see that we have some header flags. So let's look into them. Click the little arrow here on the left-hand side and open up the flags. We should actually move over to PC1 now to do this because we want to compare with what our publisher has actually been transmitting. There we are, we have the same information, obviously, over here on our publisher. Open your Python program so that we can compare with the program settings and what we see in Wireshark. We saw that the topic was plant 1 temperature. We find that over here. I have actually cheated a little bit and set the payload to permanent 9. The QoS, quality of service, is set to 0, and that is also what we see over here. These 2 bits here are set to 0. The retain flag is set to 1, set by this bit. We didn't set any duplication flag. This is per default in the Python program by the Python module we're using, set to 0. What about the message type? Where does this combination, it says 3 here, where does that come from? It is set by our program, but why is it 3? Here we will have to look into the actual MQTT version 5 standard. So I'll bring that up. And we are looking for the publication flags. Here in section 331, we find the publish fixed header, and we can see here that 4, 5, 6, and 7, that is actually the pattern that we see over here. So this is signaling to the receiver that this is a publishing message that is being signaled, in this case, to our broker on PC2. How did we know that it's a publishing message? Well, it was indicated over here by Wireshark in our capture. So we have to look it up over in the MQTT standard paper. We can concentrate on the MQTT communication between our Python program and our broker. We do not have to think about what is going on the other layers when we have our TCP connection working. In Wireshark, we can check that our MQTT settings are done by our program as we expect.